Thank you. Thanks for the confirmation. Yes, let's then get started. Last week we completed till the last slide. Actually, yeah. Let's kind of quickly have a look at it. Yeah, we discussed this one as the last slide. We'll be starting with the performance assessment. So while the work is going on, we have to constantly monitor and control the project because and it's quite obvious that what we may plan will not work as per the plan always 100%. So there will be some bit of plus minus which will continue to happen. Variations will be seen, and yes, we have to be watchful and we have to constantly adjust the process as per the plan so that the we don't get into the trouble of having a change request done. So we want to use the change request as an option as the last resort. So it's not a favorable situation because more change requests, that means you were not good enough as a project manager in terms of anticipating, in terms of estimating and all that. And yes, in terms of controlling the variation. So it's not a bad sign. It's not a good sign rather. So we'll like to kind of make sure that we can keep a close eye and correct the process before it gets too far. So that's what we'll be covering in this section of evaluate project progress. So let's kind of get going with this. So more of a checklist. What do you monitor? What do you cover up while you go through this monitoring the process? So while the work is going on, you will be required to constantly keep checking your scope because remember, this is the scope is the work and only the work which needs to be done in the project. That's the definition of scope. All the work which needs to be done. That's all. And nothing else will be done unless there is a change request. So unless there is a change request, then obviously there will be new work added or the scope will be modified. So unless there is a change request, we'll continue to work on the scope which is available with us. It's a baseline. So we'll kind of constantly look at what percentage of scope has been completed, what is pending. So we'll try to go and make sure in the end, our objective is that 100% of scope should be completed. Everything that is as a pass for the scope customer gave you as requirements, you made a project scope. So you had a customer requirements captured when that was captured in a document called requirement traceability matrix, RTM, and based on which you prepared a project scope statement, based on which you further develop the WBS work breakdown structure. See all the work which is there, which needs to be completed, and that's why you would have done a scheduling, you would have assigned activities. So all in all, as the work goes on, I will constantly keep on checking. Well, practically the work, how much is pending, how much is completed. In the end, everything should be completed 100%. So that's what I will be constantly monitoring. Well, throughout the project, I will be constantly monitoring the schedule because I have a plan, and that's the schedule. Like you already got a baseline. The schedule baseline is there, so you are doing the job, and now you all have to check is whether it's as per the plan or not. Well, are we ahead of target? Are we behind the target? Or are we on target? So please keep this in mind. Variance will always be calculated as actual minus the plan. Actual minus plan will always be the way you will calculate the variance. So whatever, if we are ahead of time, great job when doing good job. And there will be metric we'll be calculating in a moment, like we call SPI, Scheduled Performance Index. So rule remains the same. If SPI is greater than 1, we are doing great. We're ahead of the target. If it's equal to 1, that we're on target as planned. If it's less than 1, then you have a big problem. Well, then you are most likely going to be creating a change request, or you'll have to do a fast tracking or crashing because you're behind the schedule. You are not on target. So they will do this calculation in a moment. So all in all, we have to constantly watch out for this SPI as index and keep looking at it. I need to speed up the process or not? Well, we have to constantly look at it. Same goes for budget because you have a budget baseline also. Again, variance will be actual minus plan. And you would constantly keep checking out whether, well, again, there is a metric called CPI. Same rule for CPI also. Greater than 1, great job. You have so whatever budget you have finished, the work which has been done is more than that. Great job. Well, technically you're utilizing less money and you're doing more work. That's what I do is advisable. Equal to 1, that means the way you plan, you're spending accordingly. But if it's less than 1, that means you're spending more and getting less work done, which is bad sign. Again, a warning sign for change request. So you'll constantly monitor. Rule are same. Good. The better part is that rule are same for both of them. So just keep watching out. You should not be less than 1. Even equal to 1 is not good. Always want to be higher than 1. Now, if in case we are running behind the funds, then you got to neatly look for change request, justify, give the clarification why, what happened, why you sort of end up, why you have like burnt more money than it was supposed to be done, and yes, you have to go and check out for the get the approvals done. During the project, while the work is going on, you have to constantly monitor resources. Resource will be the human resources, the non-human resources, everything. So while you have to monitor, well, when I get the job done, like say I get the resource, human, like I'm talking about right now, the human resources. So if a vendor has been onboarded through a procurement process, this vendor has been assigned to you that this vendor will be responsible for completing so and so deliverable. Now, you need to make sure that this vendor is given the required material and all so that the vendor can do the job. When this vendor is doing the job, this vendor has to be given a constant, you have to monitor what this guy is doing. You have to give a constant feedback about this job. And if this guy is facing some problem, solve the problem. Bottom line, now this guy is a part of your team. I have to constantly monitor this person's job and just give this person required help, what needs to be done. And once this guy completes the job, then the quality control team has to check whether it's acceptable or not. Well, that will be, if it's acceptable, becomes verified deliverable. If it's not acceptable, then it's a change request. If they approve, then it goes to the customer and the validate scope process, validating scope, where the customer will see whether it's good or bad. If the customer says good, then it becomes accepted deliverable. If the customer rejects, it becomes change request. So bottom line, I will wait for both the customer to finally verify and make it accepted deliverable so that this guy's job is over. I will not hold on to resources. If the job is done, I must release them because there's cost for everything. So I only procure resources when I need them. I will release when I don't need them. Bottom line, the job must be done. And yes, during the entire thing, well, I'll have to constantly look at the allocation, which resource, if for that matter, non-human resources also. I may have got a truck, I may have got a crane, a forklift, or some machine. I must return basically if I don't need it. And yes, as the job is done, you have to let the procurement team know this person's job is over. And yes, you may pay, and bottom line, not my job. So you can pay this guy because all the job is done. Customer has accepted it. So this guy's job is over. You can pay him and her, whatever. And yes, while the work is going on, you continue to do performance appraisal. So that's the part we do. And apart from that, while the work is going on, you do the quality part. As we discussed, quality work always constantly goes on. So you will keep giving them the required inputs about the quality performance, how the work is done, what is the standards and all that, the needs of the customer, needs of the business, internal, external, regulatory compliance. You keep giving them inputs, required inputs. And yes, if they have made an error, then you have to go and give them feedback and just do the recommended actions. And yes, that will result in a change request. So this job is going to be done, and which is by the quality. This is going to happen throughout. Having said that, you may have prepared an amazing risk register, a risk register which has all positive, negative risks, which is uncertain. It may happen because if it happens, it becomes issue. Then we call it as issue log, not a risk register. So issue log is only for the negative risk, which has actually happened. But risk register is all about possibilities, all positive or negative risks, which may happen. Now, you may have prepared a great deal of a risk register, amazing job. You would have done a risk management plan for that. What if this happened? We'll do this and we'll do that. But while throughout the project is going on, you will come across new risks. You can't sit down at once and then plan for every risk. Risk will come with time. Risk will come from nowhere. So you have to constantly evaluate your risk and whatever is going on, because when the work is going on, new risk will be identified. So yes, you constantly work on the risk part. So constantly monitor, because you can't just sit. The moment you say, well, it's over, practically till the time the project is over, risk is not over. So yes, you have to constantly monitor these things. It's more about the list of the things you might want to constantly monitor and control throughout the project. This is what we'll be. And we'll be seeing some basically on this topic. There's about some graphs and charts we will be looking into, some calculations, very, very basic calculations we'll be getting into. So how you measure it, what kind of reports are presented, we'll be checking them out. That's all it's all about. So let's quickly check them reports and all. I guess that's what we'll be getting into. Again, still a checklist. What are these? Are performance reports. So what kind of reports? And yes, tailor if required. So every company will have their own way of kind of looking at reports and planning these things. But again, this is some list of things which you can plan definitely, and you can decide your project, your company, you decide. So sort of a milestone report, it's all about schedule. So are we on schedule or not on schedule? Some report can be prepared for that. Quality related reports would be there. This is the calculation part I was talking about, SPI, CPI thing, which is earned value management. So we'll do the calculation. So some report related to this SPI, CPI can be there. Variance analysis, which we will be seeing right now in a moment. So again, that's going to come from, if you remember the variance part of it, when the work is done, you get work performance data, which is meaningless information, but that goes to controlling process. And then you do actual minus plan, and then you get to know work performance information. And then work performance information goes to the controlling process, and it becomes work performance report, WPR, work performance report. Plus, then the recommended change request will be done, and that will go to the change control board and the process group, the process name is perform uh, integrated change control, where the change control board will look at the work performance report and the change request to see whether it should be approved or not. So again, this is all about reports. And yes, you may have a dashboard which has a integrated view of all possible reports. You may click here, you may click here. So it depends on your own needs of the project. You may have a schedule showing here, a cost showing here, and all those details. Well, your deal, like how you want to do it. Work performance data. Okay, give me one quick second. Danish, we talked about, like, if you recall the structure we talked about in execution process. In execution process, when we do the work, every day the job that we perform, it creates work performance data. The output is work performance data. Output is of no meaning. Well, if I say, like, if you recall that we had a discussion about that, like, say we have to do excavation work like 10 cubic meters per day, and you have done 8 cubic meters, it's meaningless information. But again, when you compare with what was the target, I see, okay, well, my target was 10, I've done 8. So, okay, let's just to quickly summarize that. So when I do the job every day, based as per my execution process, say I hypothetically delivered some output as 8 cubic meters worth of work I did. This is called work performance data. This is just an output, neither good or not bad. I don't know. When I compare, when this information goes to the controlling process, when I compare with the target, I see, okay, well, what was my target? I say, okay, my target was 10. So I have done actual 8. My target was 10. So I have a negative 2 cubic meters of variance. Now, this is what we call as work performance information. Now, that's a meaningful insight. Well, I know I'm behind. Now, this will go to the controlling process, where we will be preparing the reports, which is called work performance report, where we will showcase that this has happened, what happened, why we have a negative variance, and then we'll recommend the change request. Do you recall that conversation? So output that we create is work performance data. It's meaningless unless you see what's the target. Again, these are all reports only, like a list of reports. You can decide on that. So all in all, what you do in case of predictive, you have a baseline, and that's what you got to keep in mind. So you have a baseline, approved version of baseline, the project scope statement. You have a baseline. It has WBS, all the work which is deliverables, and a related WBS dictionary, which tells you the details, because WBS will have 1.1, 1.2. I don't know what's that. So the dictionary will give you what is 1.1, what is 1.2. That's it. So basically, that's what your scope baseline is. And what's your job? Measure the work completion, because you have to complete 100% of it. Whatever is in your scope baseline, finish it. Everything that was given has to be completed. In Agile, well, don't worry about it. You have a backlog. That's all. You started with 100 user stories. While you keep doing sprint after sprint, the team will keep pulling the work. In the end, I need this 100 user stories to be finished. You keep pulling the work. In the end, I have to finish this job. So you have initially you have a product roadmap, you create a release roadmap, and then you have a backlog. The backlogs will, the product owner will reprioritize the backlog. The team will pull the item. So we keep pulling the item, and the number of user stories keep decreasing. In the end, all the user stories should have been finished and accepted. So as and when we keep doing the job, every user story, as per the definition of done, which is going to be given by the product owner, will do the job. The sprint drill, how it works. So you do the job in the sprint, get the demo done, which is the review period. Then you have a team retrospective. Again, the team will ask the product owner to reprioritize the backlog. Again, the team will pull the item, do the second sprint. But before you then start the second sprint, they'll ask, okay, what is the definition of done? So my team will keep that definition of done in mind. They will do the job. Again, same cycle will go on. So here I have to finish this backlog. Here I have to finish this, the entire scope which we have created. All in all, everything that you have agreed and committed, you must deliver the job like everything which is pending, that means your work is still not done. All in all, but you have to complete it. So you don't have a scope. In case of Agile, we can't use the word scope. We have to use the word backlog. We cannot use the word scope in Agile because you don't have scope. Scope is all about planning, but you have done enough planning here. You don't. Here you have backlog. The term is backlog. We have to stick to the word backlog. But honestly, it is actually a scope. We can't use that because Agile, we have to go with the terminology which is in the Agile and not as per predictive. So going to the next one here. Now the question for you. Have a look at it, and please, the options are right here. So, well, you have to select the correct answer. Like, what is it? In a predictive development approach, which artifact helps determine the acceptance criteria? A, B, C, D. Acceptance criteria. Acceptance criteria. Which artifact will have acceptance criteria? Yeah, that's correct. That should be. So acceptance criteria will go at the scope level because the customer gives you requirement. That is not when you break it down, and every requirement you'll have a definite acceptance criteria decided. So scope statement, you're right about that. Second one, let's see, what is it? In adaptive world, what helps determine acceptance criteria for user stories has been met or not? Yeah, you're correct about that. Again, definition of done, because that's what you have there. Let's kind of check this out. Well, what is it has to say? Clear the things. Let's kind of answer this. Okay. Scope statement, perfect. Definition of done is also correct. Perfect. Yeah, makes sense. So we will be, again, still now we're talking about the reports which will come in. We will be looking into some sort of charts. Well, you may have a Gantt chart which can be presented. It is based on what kind of tool you're using, Microsoft Project, Jira, Primavera, whatever. You may have some sort of charts prepared there, which will Gantt chart will tell you how you're doing, and basically that can be done. And these are related to the quality, like the calculation part, the earned value we talked about. We'll be doing a calculation right now, SPI, CPI thing. Quality metrics related reports, again, it's going to talk about the same thing. Variance analysis based reports will be there. So we will be seeing all those elements there as we move forward. It's more of a preface or an index for the things we'll be looking into right now. Let's see. Starts here. So list of all those things we will be required to do. So again, still an index for us, but again, let's see what all we'll be seeing next. So you can have these reports through like a physical or electronic way. Do whatever you want, doesn't matter. It can be any kind of method. You will be looking into now burn up chart, burn down chart. We need to understand when to use burn up, when to use burn down chart. What is how we understand a burn up or burn down chart. We know what is information related. Large TV screens, you can use this for a TV screen, a Kanban board, a notice board, probably in a electronic medium, you may have a dashboard. Well, that can be used for as an information related, a large TV screen to relay the information to people in a large scale. Now, we'll see cumulative flow diagram. That's coming from Lean, actually. When you talk about Lean Six Sigma, the Lean part of it is like related with this, not the Six Sigma one, but Lean part of it. It's actually picking up from Lean. All agile approaches use Kanban boards, and Kanban boards are actually from Lean. So this concept is the cumulative flow it's talking about. It's all related to Lean concept because it uses Kanban, and Kanban, like Kanban, is actually Lean stuff. Yes, look at this. Continuous flow method approaches throughput. This is Lean concept. Lean concept. The work. In the end, I need this 100 users, not that. Cumulative flow diagram, that's coming from Lean, actually. When you talk about Lean Six Sigma, the Lean part of it is like related with this, not the Six Sigma one, but Lean part of it. It's actually picking up from Lean. All agile approaches use Kanban boards, and Kanban boards are actually from Lean. So this concept is the cumulative flow it's talking about. It's all related to Lean concept because it uses Kanban, and Kanban, like Kanban, is actually Lean stuff. Yes, look at this. Continuous flow method approaches throughput. This is Lean concept, Lean concept, Lean concept. We'll see that. We know what is velocity primarily. Velocity is all about average user stories that you're processing. On an average, how many user stories you're processing per sprint. So we'll see a sample, like all of these charts will show up. So we'll just need to understand what are the different kind of charts and what do they mean, like how to read and interpret them. Starting with the first one, I guess. Yeah. Very important one, burn down chart. And I would like, so this is probably my favorite one. Well, I would say why, because it helps you to understand what is going within a sprint. So please keep this in mind. When do we use it? Burn down chart I will use for within a sprint. In Agile, I'll use it within the sprint. One sprint is going on, I will use this burn down chart within sprint. In case of Agile, SP, oh goodness, sprint in case of Agile. And I can use this burn down chart for otherwise also for cost. I want to showcase how I'm burning the money and how the money is depleting. I can use burn down chart. Let's see how. So let's stay in the context of within the sprint Agile part of it. And then we'll understand how can I use this for cost also, which is logically we'll understand why part. It's burn down chart. So something is going down. So technically I would like to understand how within a particular sprint, one sprint. Say we had sprint starting here and sprint ending here, one sprint. So while for that sprint, say hypothetically, look at this. This one represents a plant. This is a plant. This is actual. We had this sprint started with like say 190 user stories, roughly looks like that. We had a plan of 190 user stories to be finished in the sprint. On the day one when we started, we had total of 190 user stories to be completed in one particular sprint. Now, looking at this chart, do you think I'm doing good or bad? That's the first question. You know what's planned, what's actual? So are we doing good? Are we doing bad? That's the kind of question you will get. This is the kind of question you will get in the examination. You may be given a chart and they'll ask you, are we doing good or are we doing bad? You are doing good and you're doing a very good job, ideally. Let's see why. Let's try to relate with it. We're doing good job. The top layer is the line is the planned one. This is the actual. Let's talk about the planned first. We started that 190 total, and we have to finish this 190 by the end of the sprint in like whatever days we are within one sprint. We have to finish all to 190 user stories. So our plan was at the end of day 2, we would have finished about 10 user stories. This is where we should have been 180. That's 180 user stories. By the end of day 3, roughly like 170 user stories. This is by the like this. Let's call it like say 160, 155, whatever something like. Let's call it 160 only. Let's call it 160. Let's call it say 140, 150, something like that. 150. This is how we are looking at this was a trend, expected trend. Look at this. Day 1, we started with 90. Day 2, we should have been at 180. Do you think my team did a good, like faster job and we were at 170 instead of 180? We had only 170 pending. We were supposed to be at 180 as per the plan. We have 170 left. We were supposed to be at like if you look at this plan, we started with 190. The plan said that by the end of day 2, like when we start day 2, we should have 180 user stories in a backlog. How many did we had? 170. Do you think my team did a good, like faster work? We only have 170 pending. Now, day 3, we were supposed to be at 170. My team was doing, let's say, whatever, this 160. So my team is faster. This was about, say, 160. We were doing it somewhere here. Look at this. The team is kind of doing ahead of time. Like, let's pick up for this day. Say, this is 120. We were supposed to be at 120. User stories should have been in the backlog. My team has roughly, like, say, whatever this called is 985 or whatever, 85 user stories pending. So my team is doing work faster than what was planned. As of that day, my number of user stories pending in the backlog should have been 120, but we are doing at 180. We have 85 only pending. So team is doing faster. So the gap that we have created has helped us. Look at this. At one point, we stopped moving. Probably we found a impediment. There was some problem. The work did not move. Work did not move. And since you were able to create a gap here, you were faster. You were still safe. You did not move user stories, nothing. Look at this here. Till here, it was almost a flat line. You were still able to survive. Why? Because you had created this gap. Because you've done the faster work, you were able to survive here. And now, well, probably there was some problem which was rectified, and instantly you finished the job one day early. But again, you were able to survive for 3-4 days constantly. There was no improvement, no user story completed. And that's why we had a flat line. So thanks to this extremely good work we did in the beginning, so we were able to save time, and that save time was able to help us. Otherwise, we would have crossed. Well, think about the situation. This would have continued. Assume this would have continued, and we were not. Do you think this would have been a problem now? This would have been a problem if this continued. This would have continued like this. No changes, no changes. That means I was supposed to have this much, but I have this much, which is more work pending than planned. That would have been a problem. So if this would have continued, I would have been having a problem. Where is cost saving through work is done against? Okay, Tushar, it's not about cost saving. When we talk about when we're doing the work, as the work is done, we're tracking the work. Cost ways stuff is different. Like, so I can plot this for cost. I can use burn down chart for cost. This is only for iteration. It's only for the iteration, the user stories. We're trying to track the user stories. And that helps you to understand, are we on track or are we not on track? Cost-wise, it will be a different chart. So this is how you're doing it. Now, can I make a similar chart for cost? Say I started with my plan, like if I'm doing it in a predictable. If I'm doing in a predictable, can I use a burn down chart? Yes, why not? I started with a budget of, say, this 190K. The plan was this is slowly, steadily will keep on doing. And this is my spending. So if I'm spending less, well, am I doing good? Yes. So whenever this actual is below the line, it's good. Whenever the actual is above line, it'll be bad. So all in all, you got to keep in mind whether my actual is below this target line or like anywhere where cost is lesser the better. So if my actual is lesser the better, then pretty much this is good. But if my cost exceeds this, it will be bad. That means we spend more money than what it should have. So all in all, if you line this line, say hypothetically I'm making this line and it crosses this, if this assume forget about this, it would have continued here, here, and I would have not moved. And this is the cost pretty much. I would have taken more money in that case. I have taken more money. So the money that I should have actually spent is this much. I have spent more money. What tells me? So anything which is exceeding the line will be bad. Anything below the line will be good. So all in all, the same thing. Ideally, this is from agile perspective. It's used for knowing that, like tracking the user stories completed, and it's used within a sprint. But I can use this for cost also. I can use this for looking at the cost spending also. And it is very good representation, like how much is spending, how much money is spending, how much have we spent. So it will help us understand the variance part. Is it okay and clear, the burn down chart? Quick one with this. Okay, let's check out the burn up chart. Burn up chart is used for sprint by sprint. It's not within sprint. We're talking about relax one sprint, second sprint, third sprint, fourth sprint. So that's okay, back on note. Okay. So here it is when you say burn up chart, it is as we adding up. So here the previous one was about depleting it. Now this is adding up. It's going up. So when we use it, burn up chart is used ideally to track the releases, how you go up to release part. So let's try to understand here. So when we started initially, in our product backlog, we had say 100 user stories. That was initially agreed. The backlog had 100 user stories in it. So that was so in the first sprint, like so it's not within the sprint by sprint. So what it tells me by the end, when we completed first sprint, we just completed about 10 user stories at the end of first sprint. In the second sprint, we moved another 10 user stories. So 2 sprints completed, 20 user stories completed only. Then in the third sprint, we have actually taken a jump here. So that's when we took a jump, and this is like roughly like let's call it 40. So we did about 20 user stories here. Then we were moving 10. Now we did move to about 20 user stories in this particular sprint. But again, here also like we moved about 10. And so technically we're just moving more like you generally see, it's moving 10. But at this stage, look at this stage. This stage, what it looks like, we were at what number user story? Like say, let's call it 50. We were at 50 user stories completed. And in our backlog, we had a total of 100. So that technically we started with 100. So that means 50 we have completed, 50 was pending at this stage. So at this stage, 50 user stories we have completed, and remaining 50 were pending because total user stories were 100 initially when we started. So at this stage, what it looks like after this demo, the client might have added 20 more. Look at this from 100 to 120. So client might have added 20 more user stories. So the count, like now, like we've got 20 more added in here. So this looks like there is an increase of 20 more user stories which were added. Now we have to catch up with the 70 now. So we trying. So this is where we are able to see sprint by sprint how we're moving and tracking, like going and touching that total number. So yes, it's adding up. And you say burn up chart is adding up. It's not within the sprint. When you want to see what happens within the sprint, you do burn down. But when you are looking at release wise, how you get to that point and you finish up the total work, you will be doing a burn up chart. And this can help you to even add up the work. So this can be shown that when after which iteration the product owner probably might have added user stories. So all of a sudden, the backlog count, which was initially 100, and that was increased to 120. So now we are doing a catch-up game and to get it there. So by the end of 8th sprint, we are here. So let's see, where does this velocity, remember the velocity topic, we talked about velocity, average number of user stories that we process. Now let's say, hypothetically picking it up, this scenario here. At this stage, say we have, let's say 4th at this stage. Let's call this stage. Where this velocity part will come into picture. So this is the total plan. Like this is where, let's call it like 40. Let me just call it 40. So you completed 40 user stories and the total were 100 to start with. So at this, if I look at, we have done 4 sprints. So what is your velocity? What is the velocity if you have completed 4 user stories? 40. Amjad says 10. Is your velocity 10, everyone? Is your velocity 10? Average? Yes, because you have 4 sprints done and totally your finish is 40. So 40, like your total of 40 user stories divided by total number of sprints, you got 10 user stories. 10 user stories per sprint you're doing. So your velocity is 10. Now, hypothetically assuming, now if you have total agreed sprints to be completed was 8 only. So now you have 4 more sprints left over. And how many more you have to complete? 60 more user stories you have to complete because you are at 40, you have to get 100. So you have to do 60 more user stories. And how many more, like not this one, not this extra one. I'm like just adding the only 100 part of it. So from this standpoint, so forget about this. I'm just trying to make sure where do you use the velocity part. So you have 40 user stories completed, 60 more to be completed, and you have 4 more sprints left over. Now, if I continue to do this job at the same your velocity, 10 multiplied by 4, I'll end up completing another 40, which will be, I will be left with 20 more. So do I need to increase? Yes, Amjad. So what should be my velocity? Amjad has mentioned 15. Yeah. So I know if I continue at the same rate at this stage, if I look at my velocity is 10 and I have 4 more users to 4 more sprints left over. So if I continue with 10, I will not be able to finish it. So I know I have to increase my velocity to 15 because I have got only 4 sprints left over. So if I maintain a velocity of 15 and with 4 more, I will be able to finish this. So that's the plan. That's where the velocity comes into picture part. So we'll be able to use velocity here. So to see how much is spending, how much we have to improve. And yes, for that, I may have to increase the resources, do whatever you want. But again, you can't exceed the time. So if I have to put more resources, I will put more resources now. I'll have to look into this, like doing the speed up the work, less of error, less of like. So I will try to ensure that I don't go and like breach that, because time is the worst thing that you like. If you can violate the time, then that will be a problem again as per the contract. But again, this is where you look velocity part comes into picture. So burn up chart will help you to understand how you move from sprint to complete the backlog, and this is where your velocity part will come into picture to kind of look into it. Are we maintaining the right velocity or we need to increase it? Is it significant to find? Yes, it is. Otherwise, without knowing that, how would I know, am I on maintaining the right track or not, right speed or not? Because if I just continue to work without knowing what is, let's see, if I would have continued at the same rate, by the end of 8th sprint, I would have only finished 80. So if I do only 10 user stories per sprint and I have 8, then I'll end up doing only 80 only. So without knowing what's my velocity, I will not know, am I on the right track or not? Is it clear with everyone? So burn up chart is linked up with your velocity part and it's sprint by sprint. But burn down chart will be within the sprint, how you're finishing the work, whatever planned work is there. That was burn up chart, burn down chart, very important ones. You could get a question like that in the examination. Well, they will ask you whether it's good or bad looking at the chart. Now, this is a Kanban board. Well, task board, Kanban board, we already seen, like we already compared with the Kanban board and the sprint kind of thing, remember? So whenever a user is available, they pull the work, the Kanban board. I hope we all recall the Kanban board. That's what it's talking about. That can help you to understand how many user stories are pending, how many are like which. So it is always going to be there. But there is a strange thing that the first iteration was, okay, let's go back and see. From first iteration, like this is where we started. So when you complete the first iteration, like this is where technically we started here. Where the first iteration, we started with the 100. This is the work which was completed was here, the 10. So not we start from the beginning here. It's a day one pretty much. We like this is where first completes and second starts. First completes and second starts. So work will be counted here. Is it clear? Is it okay? So this is where we're starting. First iteration is starting, and this is where how many we complete? 10 in the first iteration. This is where we have the demo. 10 was finished. So we started here on technically. The starting point is here on. It is supposed to be continued. It will be supposed to be continued. So here we have completed. Here we are completing the 7th. Like so, from here till here, it is 7th which is completing. 8 will start. 8 will start from here. Yeah, it's starting from here. It's starting from here. The first iteration is starting. With 8 will start from here. 8 iteration will start. So 7 is, see, look at this. First from here till here. Second from here to here. Third starts from here to here. Fourth starts. So it will be more of a continuation which will be required. Is it clear? It is more of like it will start from 0, obviously. Day 1 will be starting. Update after. Update after each iteration. That's what it says.
Excuse me.
Yeah.
Can I talk better?
Yeah, please.
Actually, we are discussing just to understand more. Your explanation, it's good for me, but what I understand here from the slide, it's updated after each iteration. So if it is updated after the first iteration, that means the first iteration was 0. If we consider it is the beginning, this number at the beginning of iteration, the first iteration. So the 8th iteration, the last one, it is not yet updated in the file.
Okay, so you see here what we're saying that there was no changes done in the first iteration. Like are you saying that there was no work completed in the first iteration?
Yes.
I'll have to. I can check.
This is based on this example. Our discussion just to understand this example in particular.
See, well, I can be wrong also. No, there's nothing wrong with it. I can just check. So show accumulated and progress completed work. Update after each iteration. Looks like. But again, there's no line. That's what I'm see. My only apprehension here is that there's probably the image needs to be corrected, whatever. But again, because there is no line, otherwise I would have started from here. See, the only problem I have here is it should have plotted a line here. Somewhere a line should have been there. That's what I would have assumed that there's no work done.
It's okay. It's okay, sir. No issue. But based on my understanding to burn up, let's say feature or graph, I am with the update after each iteration because you are updating the progress.
We're supposed to. So, okay, when we talk about, we are supposed to update after each iteration, right? So technically, so my iteration starts from like, that's what the way I'm reading it. See, I would have tried, the only way I would assume this is that 0 work is done. If this chart would have had any line here, I would have said there's no work done. I would have agreed for that. Like I would have said there is no work done if this line would have been here. Probably the chart needs to be extended, but if I take it, I would rather keep it like it starts from here itself. Because it starts from here.
Yeah, the line. Yes. Okay, I got it.
I would agree with this line. If this line would have come, like they would have plotted a line, that means there's no work done, no improvement.
Yeah. Can I say something here?
Please, Ruxana.
Anything when it touches the axis down, which means it's a zero. This is a graphical representation when we do economics demand curve and everything. So anything which is touching the axis means zero. So not necessary it should start from the origin. It can start on any line in the axis. Hope this helps to understand.
So, okay. So pretty much when we're saying that, like what do I make in like meaning out of this one? That's what I'm trying to figure out here. That we did we did no work in here in the first iteration.
No, but
and that's what I'm trying to figure out here. Does it mean, because see, wherever you will see, let me quickly show it to you. The previous one, if you just try to relate with it, you will probably understand my attention to calling that there's no work done. The reason being, if you look at it, it will always correct. Look at this. Can you see this? We completed, but again, do you see the red line? It said it will continue till that point. That means we maintain. Yes. So, well, if I look at the next one, I'm not able to see that if there was zero work done, there could be a fault of the chart, which is absolutely fine. But if the reason why I'm calling it that it's starting from here, because otherwise I should have seen, I'm saying this was first iteration completed and there was no work, I should have seen a line here like this. Then I would have counted it as it started from here, because there's no line. Again, that's what I'm believing that it's all starting.
No, if you see the parallel lines, which is shaded white and then purple color and then white. So there is a gap, which means it is the full bar, no? So the first iteration started. So by the time you come to second one, it reaches to some number. So it started from zero, but then you reach to certain amount in iteration 2. So previous graph also, if you see in June, there is no particular point. It's like a bar, which means there is a gap. So within that space, you started in June 1st. So there is a gap bar, no? There is
Agree, but actually the technique for both
try to kind of get.
Are you hearing me?
You probably see it could be a glitch with the chart. Let's kind of try to see a burn up chart.
But there is a different technique between these two let's say graphs. The burn down technique, it is updated since beginning. What's remaining with you?
Again, that's also, look at this is starting, like it's giving me a 0, and look at this. It is from 0, it's moving on till 1. This is where we have moved some. Look at this. If it has to,
but this is iteration 0, sir. This is iteration 0.
Start from somewhere, so it has to. I would see that connection. Like, so my only apprehension is that if it remains, I would see that connection. If there was no work done, I would have seen, like, my only apprehension of not calling that there was, like, if there was no work done, I would see a flat. I should have seen that there's 0 and there should have been a line there. That's my only, so we may, so from the only apprehension I have is of not calling that as there was some work done there, because primarily if I say there's some work done, like there was no work done there, I would have seen a line like this, the way it's connecting here. So technically, I still see it. The work was completed 19th June, but we still say that this could become, now it's become a status quo now. So it is, if I look at it.
But for the burn down, the update will be at the beginning of a certain period.
See, for the was finished here. If I look at the burn down, the work got finished at this point. The work got finished.
We are updating it at the first of each day, let's say.
Yeah.
But for the burn up, we are updating it at the end of each day, or at the end of each iteration.
Iteration, right? Well, so, and that's what we're saying. If I'm saying here, when we completed the first sprint, I should have seen that there is, like, so if there was no work done, I should have seen a line. If it's starting, so we say iteration 0, probably there should have been a line connecting. There was no work done, 0 completed. I should have seen, probably it's something to do with the graph, or probably, and we say the only my apprehension is I don't see a line, and that's why I would want to call it as it got updated. So I'm saying that it started here and it ended here at the end of first sprint. It started here, it ended here. So that's why I'm counting it that way, because there's no line here. Otherwise, I would have read it that way, like starting from here. The first sprint we had no work done. Second sprint we had.
But by this, the chart, it's against what's mentioned as a description.
Which one?
Which is update after each iteration.
The update, like, so it's supposed to update after each iteration, right? That's what it says. Update after each iteration. So whenever you're trying to update it after each iteration, technically, so this point is they're talking about this should have been. There's a graph which ideally should have, like, so this pointers we're talking where we have reached after each iteration. Ideally should have been counted that way. But then there is a glitch in this graph which has to be corrected probably. Then I need to highlight it to these people. Well, because I should see a line there. If I'm going to go with this line, ideally there should be a line which should connect with there was no work done.
Clear, sir. Clear, sir. Thank you very much.
Without absolutely see, there's nothing. See, honestly, good that we are able to have a discussion and here. So without any doubt, like things which needs to be clarified. It's not that I will always be 100% right. So we'll see people. We all have been working in the same industry, and there are things which we definitely want to kind of make sure that. Then that's why we would like to. It was good that you pointed it out, and it's good at least I will be now able to kind of put a note back to these folks and say, well, give us the clarity. Okay. Well, where there should have been a line, or probably give me the clarity.
Thank you, sir. Thank you.
Thank you for bringing this up, sir. Thank you.
Simple thing is we can name it as iteration 0, 1, 2, 3 and make it 7 instead of 8.
Yes, probably. So I would say something needs to be corrected on there. Yes, absolutely.
Yes, this is better labeling. Yes,
clarity. Yes. Good that you brought this up. So I will be able to at least check with these guys, because bottom line, there is something which I'm also not convinced now. So now definitely good that somebody, like, I've been looking at these slides for probably so many times. I've never, like, nobody pointed, nor I probably watched it. So good that observation comes from someone at some point in time. So thank you. I will not.
Hi, Shashi, Farooq this side.
Yes, Mr. Farooq, please go ahead.
Yeah, hi. So I just wanted to add on a point since the discussion has arisen. Let me share a point of experience of mine. So see, there are two categories. One, some team, they start with iteration 0. That's completely fine. Other one, they directly start with iteration 1. So what does it mean? So iteration 0, as you said, of course, we have mentioned it, iteration 0. From iteration 0 to iteration 1, some kind of work has been done.
Right.
Here also it is the same scenario, but the problem what has happened here is we do not have iteration 0 as a label here. It doesn't mean that. A good example, we just wanted to start a work. We are given 5 days of time. And during this 5 days of time, we were working. And at the end of the 5th day, we had a review, that got updated. From 5th day onwards, it carried on. So that is how this chart goes. The reason why I'm sharing this is because I have witnessed both the scenarios in my kind of an experience, both having iteration 0, starting with iteration 0 and starting with iteration 1 as well.
Okay. Well, so good that you, so I have definitely, but I would, good that again, you at least have one more aspect. So when I'm going to write an email, so I'll put it. So at least I will be able to share the feedback that I got from the people while having this discussion. And yes, I would want to hear their perspective when they made a chart. Well, do they also find this as an issue, or they have a justification for that? So I'll
for sure they'll be having a justification.
I do agree with Farooq, actually, because either they add the iteration 0 or they add another iteration after iteration 8 to update the progress of iteration 8.
I would definitely want to have the clarity here. But again, that's good that we have this, at least I would be definitely.
Thank you all. I'm sorry for inconvenience and disturbing this.
Makes sense.
That's can continue, sir.
Thank you, everyone. Yeah. So Mr. Mohammed, again, there is something which needs to be understood about, but again, logically, what we are able to, like, we got to keep in mind that these burn-up charts will help us to understand how the work is getting done, basically, as the work is like sprint after sprint. So it will be used for sprint-wise work which is done. So where velocity concept can come into picture. Yes, image-wise, again, we still have some bit of discrepancy, which definitely need to have clarity. Conceptually, we should know what is the purpose of the burn-up chart. And Diana, no, these are not available in Minitab. No, this will not be available in Minitab. Let's check out the task board. Pretty much we have discussed about this during the Kanban part. I hope you recall the Kanban thing we discussed about. There are the user stories which are there. Then they further you kind of pull the designer puts up the work, then developer pulls the work based on the availability. You recall that discussion? We did some bit of sketching and the work will be pending if somebody is not available. The Kanban board works that way based on the availability of resources. The Kanban chart is generally now this is the velocity chart, which tells you on an average how many user stories you're working per sprint. So these are like first use, like for this particular sprint, we had like say somewhere a little higher than 100. This was less than a little 100. So on an average, what's your velocity? Just average, which we already know. The velocity chart helps you to understand what's the rate of your user stories that you process. So basic stuff. We will be quickly checking this out. This is from lean perspective. The chart is very horrible. So we'll have to understand these 4 terminologies. One is WIP, lead time, cycle time, throughput. Like throughput, we'll try to understand from this chart. Pretty much it's like a really horrible one. Let's try to understand what it means. So quick one, these are all lean terms. Actually picked up 100% from me. So we'll have to go and do some bit of sketch work to create it. Okay, so here is a customer who places an order with a company. The customer places this order on, say, hypothetically, 1st of the month. And this information is relayed to the customer, like through the company. So there's a department which is technically the store and all. So this is, say, first department, like let me call it A. And they get the raw material. When they get the order, on the first, they start procuring the raw material from the vendor. There was a vendor who supplied the raw material and everything. They started the work. Then there, like various other departments were involved in this one. So when they got the raw material, production team came into picture. They started the production work. Once the production was done, then they were the team which was getting the quality control thing. They did the quality control job. When the quality control was done, practically then was like say, the packaging thing, and then there was the logistics team came into picture, and finally it was sent back to the customer. So customer placed the order, customer received the order, we did the job. This was 30th day of the month. That's how it is. So just to understand this entire thing. So first term we want to understand is lead time. Now lead time is taken as from order till delivery, everything. Order till delivery, this is my lead time. So my lead time will be like from 1st till 30th, which is like total of 30 days of your lead time. That means from order to delivery. That's what we call as lead time. Now we talk about what is, then there is a term called cycle time. A cycle time is the actual time that you do the job, actual time. So let's see what do you mean by this is the actual time here, and we'll calculate what is the cycle time. So the store, the procurement process of the raw material, let's call it like this guy, they took about say 2 days time to procure the raw material. The actual time of the procurement, the store guys. Production process, there were multiple steps involved in there. Let's say the entire production part, it took roughly like say 15 days time for production to be completed, all of it. The quality took say roughly to do this audit and all, they took about say 2 days time. And then there was this packaging team, they took about 2 days time. And the logistics team, the actual work took about say 4 days. That's what we have. So what is my cycle time? This is the actual time they took, the department took them to do the job. So my cycle time will be 2 days plus 15 days plus 2 days plus 2 days plus 4 days, which will be 17 to 19, 21, and 25. So we've got 25 days of cycle time. Now, where are the remaining 5 days coming from? That's what we talk as work in progress, WIP, work in progress. It's technically in between work in progress, or you can say even the waiting time. This is a type of a waiting time. So what happens with this work in progress? When this department, when they sort of customer placed an order, probably there was a store did not start. The procurement department did not start procurement from the same day itself. So there was probably a delay or a gap where they waited. Probably things took about 1 day. Those of processing was taken, like they were delayed in doing the job. This was roughly about a delay of say 0.5 days when they procured, but production did not start it immediately. There was a 0.5 days delay of they starting the work. When this production team completed the job, was another say 0.5 days of delay when the quality team started working like doing the job on that one. So let's call that these guys did packaging team took about 1 more day. These guys took 1 more day, and then pretty much these 2. So this is the maths around say 1, this is 2, 3, 4, 5. There was in between 5 days of waiting or work in progress. In between 2 process steps, that's work in progress. In between that, so actual time is a cycle time where work actually happens. Work in progress is in between 2 process steps, the work which is stuck, and the time basically the duration. Lead time is end to end. So if I talk about the entire thing, lead to end to end will be a component of your work in progress plus your cycle time will lead to lead time. So total time is technically the breakout. If you do this, the actual time plus the remaining time that you're looking for is going to be total lead time. There's one more terminology which is we have here. We call it throughput. The last one is throughput. What do you mean by this throughput? Like let's so I have to before we get to, because we have to do a little bit a different sketch. Quick check with everyone. If it's okay and clear for throughput, I'll have to go to Excel. Is it fine with everyone so far? What is the meaning of lead time, cycle time, and work in progress in between? So I'm going to get rid of this one because throughput we can only understand on Excel because there will be some calculations required. So conceptually, what is lead time is end to end. Order to delivery. Lead time, Mr. Mash, order to delivery. When do you order? When do you get? Total. That's total days, 30 days. Lead time is end to end. Everything. So you add work in progress and the cycle time. The overall, the end to end time is the lead time. Now let's talk about what is this throughput. For that, we'll have to understand how basically lean works this way. The calculation lean works this way. So department A, department B, let's call it department B here. Department C. Department A, so there is an input of this department received an input like they have raw material procured to do the job. They got, let's say, 100 items. They procured 100 items to do the job, raw material. When this processing happened, as a result of this processing, when we talk about the output created was, so I would say first time right output created output. We had, let's say, 85. So there were 15 defects in there. So then technically the manager of department A would look into it and they find that out of 15, the completely damaged items are 5. So we can't save them. We lost them. They were destroyed completely. And then 5, like 10 were repairable. So reworked or repaired items were 10. So the net output after rework is going to be the 85, which were the process absolutely correct for the first time, which had no problem, plus the 10 which we repaired, which is 95. And we lost this 5 because that was damaged. This is the throughput of this particular process. The items which are exiting a system, let's say kind of do that, and we'll talk about the definition then. Now this 95 goes to the next department. 95, we only received 95 because we lost 5. Now this department started their job, whatever they have to do on that item. Now, so A department does the job, it goes to B. B department does the job, it goes to C, and finally C completes the job, and the final item is created. Now, when they started processing it, the first time right output was say 87 items. So we had about 7 items which had some problem. So they got it checked and they found that 2 items are damaged and 5 are repairable. So these 2 items were lost in the process. So we had a net output of this process was 87 gold plus this 5 which were repaired, 92. This was the fresh item, technically the good items which were finally procured. Last process which will be processed here. So we had processing done and we had, like say again, 7 items which were damaged. So we had 85 items good out of it. And when we found during this process that 5 items were completely damaged and 2 were repairable. So we lost this 5 also in this process. And in the end, my output was 85 plus 2 was 87. So my net output, the customer only gets 87 items. That's what is. Now, when we say what is the meaning of throughput, throughput definition is the items either exiting the good items, only the good items, only the good acceptable items exiting a system or entering the next system. That's what is called throughput. The good items exiting a system or entering a new system is going to be throughput. This is throughput for this department, 95. Now, this process happened, the process, how much items are exiting the system, 92. And same is entering the next system. So number of good items exiting the system or entering the next process. So technically, this is again creating it, and that's why the net, because there's no exit, it's only the output which is going to be created. So whenever we talk about the definition of throughput, if you go back and see this, it's going to be the same. And yes, if you want to know the why department 92, not 93? Because we look at this, 87 were good and 5 were repaired. 87 plus 5, 92. Is it clear?
So the worst, sorry, Mr. Shashi.
Yeah.
So the worst department here is department 1, right? Department A.
We'll have to check this out. So if you talk about department A, in a lean world,
you have to continue to make the test, right? To see who's the worst department here.
Okay. So, well, we have to so depending on if we talk about lean perspective, the definition is very different.
Yes.
We can from a lean perspective, so I'm just going to talk about from a lean perspective. Throughput yield is calculated different. Lean, it's calculated different. It is going to be 85 out of 100. It is going to be, in lean, it's different. Worst department, you're right about that. Worst department is the worst department. You're 100% correct. Okay, well, give me 1 quick second here. I don't get why we have the damage is 5. And okay, well, okay, this process, they are give me 1 quick second. So we did 100 items, we got out of 100. Let's kind of do the calculation quickly again. We had 85 items good. So
there is wrong calculation in department B.
Okay, probably we made a mess.
Because 78 plus 2 plus 5, it is 94, not 95.
Okay, let's so this.
So you have to increase 1 item, either repairable or damageable.
Perfect, makes sense. Thank you.
The issue will be into.
I probably missed out then. This is perfect. Now, so we got 95.
No, sir. Now it's increased than 95.
Give me 1 quick second. So here we had 87 good items. So we had 5 and 3.
6. You can make the report or repair 6, not 8.
Okay. We had 3 and 8, a total of 8 items which were damaged. This has to be 6. You're right about that. Now it's correct. Now it should be correct.
That's it. Thank you.
Perfect. Thank you, sir. And this will be 93 here. Now, is it okay clear now? I guess I made a mistake there. Mr. Mohammed, is it clear now? Well, this is the work where they were doing. And while, see, we're just going to reiterate this. What is with these guys started working with 100 items. They had to do some job while they were processing and doing their job. While processing, the only output which came out of the process, which was 85 items, were good without any error. So 15 items were damaged. Now they looked at it and they found 5 are completely damaged, so you have to replace them. And 10 were repairable, so they reworked and repaired. So what was the good item? 85, and the 10 which were repaired, which is total of 95. Is that clear?
So the 5, what I understand, another thing, like the 5 is the minimum damage. So do you have 5, 5, 5?
Yeah, so 5 here, 2 here we lost, and so we have to actually look at the end we got 87.
Now it makes sense because it's different. So each time they are working, the team A lost 5, team B lost 2, and team C lost 5.
Yes, total we lost 13 and
now makes sense.
87.
Now makes sense. Thank you. Now makes sense.
So for the definition, wise, please have a look at this. The number of items entering or exiting a system. Number of items entering or exiting a system. This is what we call as throughput. So the number of good item entering a system or exiting. So this is exiting a system or entering the system. So from this system, it's exiting, it's entering. So what do we call this? Is the net output, which is good, is called throughput. So that's what it is, the definition. The number of good items entering system or exiting. We call that throughput. So this is pretty much on the throughput part. One element here.
The first 100, Mr. Shashi, the first 100 should be considered in the entering and exiting.
Because it's coming as input, but that's not throughput. Throughput is what will be created as an output. So see, the whatever is getting created as an output will be an input for another department. That will be
exactly.
That's input. So see, here this one is a throughput because it's coming out of the process, but this is just an input. This is just an input. It is just an input we take, but an output. The processing started. That's when we started calculation of the throughput. Throughput will come into calculation when you start.
Why I'm saying this, like if you are like I'm talking about my field now, okay? Yeah. So for us, let me say, like in the warehouses, the inbound and the outbound for us, it's our total throughput per day. What do I mean here? If I'm receiving on a daily basis like 100 or 200 pallets per day, and I have dispatched also 200 pallets, so total throughput of my process is 400 pallets per day. This is what I'm talking about. So the input here is same like the inbound in the normal warehouse operation. You got me? This is what I mean. This is what I meant. And whenever I'm delivering this throughput to the production, regardless if I'm receiving the raw materials and dispatching I'm packing it in a certain way to dispatch it to the production line. So this is the throughput. So it's going, if you are taking it from the whole cycle, a process cycle. So we consider this 400 pallets. It's our throughput as a warehouse. Then in the production, once they receive and dispatch, also they consider their throughput. At the end of the day, we calculate the whole throughput and for our to understand the whole process for our throughput per day.
Only when it comes into picture, says 100 items were supplied by the store, and if it's accepted by the production, well then pretty much it'll be throughput for your department. So please keep this in mind. It has to be a process which has to, like say, I may go and supply say 100 items to the production team, but they in that when they audit, because when I'm receiving it, I will do the quality check to receive an item. If I see that there are 5 items are not good or 10 items are not good, I will reject them and I will not accept them. So there will be throughput in case they accept everything, then it's your throughput in that case. So if in case you're the one supplying it and somebody is receiving it, there's a process which has happened. It's a process. If they have accepted, then it's a process. So, well, if they reject something, then it will be like, then it will be our throughput, then you can, because that's also a process. So if you're getting it from the supplier supplies it to your company, and like say if I have a vendor supplies it, and if like say a vendor supplies 100 items and I only accepted say like 80 out of them, I say that 20 are not up to the mark, they're not as per the requirement. So technically the throughput will only be 80 in that case. So whenever there has to be, like the process has to be there. If I'm just taking the process as coming as input without taking anything before, so the process has to complete. There has to be input coming into the process and an output getting created. So when you are saying that you are receiving an output, like the material you're giving it to the certain department, if they're accepting it, then I would definitely count it as a throughput in that case. In that case only. If it's received, if you're giving it to somebody and they're accepting it, then there's a process created here. That's similar process like that. If you all are accepted, then it's great. It's a throughput, 100%. It has to be accepted. So if somebody supplies, somebody gets it. A process has to be there. And it may, like we may be using from a lean perspective, again, this is how we calculate, because there has to be like a process involvement has to be there, because there could be something which may not be acceptable, and that's where we will have to do the calculation. And they're done very differently in terms of how you calculate in lean and in general how you calculate, because lean you do not like whether if I was talking about this, if I talk about my error-free rate, here I'm not giving a percentage. I'm looking at calculation. My throughput. This is throughput in lean. We're only counting 85. We're not counting 95. We're not taking 95%, because in the end we had 95 good items, but we're only counting 85%. That's lean way of calculating. You don't give the credit for rework. You don't give the credit for rework in lean. We were able to repair 6, but are we getting the credit for 6? No. But that's the way of lean dealing. Lean, we just do not give any credit for rework. We only give credit for first time right output. Any correction will be penalized. Well, that's a lean way of doing it. That's a separate. So all in all, throughput part is all about the number of good items either entering a system or exiting a system will be number of good items will be called as a throughput. Now, while we're doing the job, budget challenges may come into picture, and these budget challenges can be because of multiple reasons. Well, a couple of them are not my problem. Say, what if the project requirements have changed? Well, that's not my problem. Scope has changed. Customer has asked for something more. That's not my problem. We'll revise. There will be change requests. That's not my problem. This is definitely if a new risk has come into picture, because of which we have burnt more money. And probably much more money than we anticipated. We have contingency reserve with us, but that was insufficient for us. And pretty much we have exhausted more money. That could lead to budget challenges. And probably, or we may have not done a proper cost estimate. We may have not done a good estimation, and we might have taken less budget, less cost for it. And that's my blunder. That's so we might have to get into the change request process in that case. So budget challenges, one where the customer is requesting for it, then it's not a problem. But if we were not able to do it properly, the estimation, or for that matter, some significant risk has come and that has burned up all the money that we had, or like most of the money, then practically I may have budget challenges which I have to handle. And that will be handled through only change request process. You don't have a choice there. So now I'll be skipping some slides here. I'll tell you, it's all about the calculation part. So I'm just going, these are the things which will be EVM, earned value management. We'll be looking at these formulas there. So I'm just skipping these slides here, which is the calculation we'll be doing, earned value, planned value, actual cost. We'll be seeing that, all of it. Let's see, these are the formulas. We'll be checking them out in that Excel sheet, ETC. Let's leave it here and we'll go back to Excel. Now, all those formulas which we talked about, I shared them. I think I shared them last week when we were having a discussion. Let's go and look at the calculation. Now, first thing first, 99.99% of time, people have always got only these two metrics. This is only, so you might be given a scenario and they, after kind of talking about all possible scenarios, they might give you a SPI number, they might give you a CPI number and say, are we ahead of target? Are we behind target? So concept will remain the same. Well, but barring that, yes, there was some additional calculation. We can quickly talk about it. So because you never say never, you could be given any formula also. You could be asked to calculate something else also. But again, generally, people have always, I have not come across any person who has talked about like they were asked about any other formula. But it's quite possible. But most common question is all about knowing the CPI and SPI. Let's talk about how do we do this calculation. So first thing first, let's talk about this here. We have, like say, we have a piece of land, let's say like 500 yards. And I speak with a contractor consultant who's supposed to do this construction here. And he says, well, this is like like we have to do a boundary. That's it. So each wall will take 1 day. And so that means I'll finish this wall in like 4 days and I'll charge $1,000 per wall. So the planned duration is, as agreed, is 4 days, each wall 1 day. And the budget at completion, BAC, the cost baseline. The BAC is the highest point on your cost baseline. So which is agreed is 4,000. So $4,000, 4 walls, 1 wall per day, job done. That's the plan. So while the work was going on, I happened to visit at the end of 3rd day, and I was surprised. I saw that only 1.5 walls work was completed. Ideally, I was expecting 3 walls will be completed by the end of 3rd day. This is work performance data. 1.5 walls completed. Work performance data. Is it good or bad? I don't know. Now, when I will compare with the target, I will see it will be meaningful information, the target part, and I'll see am I ahead of target or behind target. But this is just 1.5 walls I see. Good or bad, I don't know. So I asked this project manager that why it's like 1.5 walls. So this guy started kind of talking about there was like a lot of rain and practically we could not work. The labors were here. We lost a lot of material also, like because while we were working, all the material got washed out due to rain. So we already wasted a lot of money here. So by the end of the 3rd day, because of the rework and a lot of labor, we had to do like some bit of extra work and to recover that and all that. So we already burned about $3,200. By the end of 3rd day, we already spent this much because I had to get some people to do overtime and all that. That's the actual budget which has been spent. Now we're trying to get into some facts here. Based on this story, what is the percentage of work which has been completed? 1.5 works completed out of the plan, which was 4. So as of today, as a total plan completed, we have only completed 37.5% of the planned work. Now that's my work performance information. That's 37.5 has been completed against the plan. And what should have been completed as of now? 3 was out of 4. So the planned completion was 75%. The actual completion is only 37.5. Now I will be looking at earned value. How much value, whatever this 1.5 was has been completed, how much value have we earned in terms of, like, everything will be translated. Time will become translated into money. Money will always be by default in money. So everything here will be converted in money. Even time will be in money. Earned value is going to be calculated. Earned value will be calculated as the percentage complete, whatever you have completed till now, of the total budget. How much, like, because you completed 37.5% of work of 4,000, which is about 1,500. So if we take 15, like what has been completed? 37.5% of what? Of 4,000, that's the total value of work which is planned. So you have earned a value of 1,500 because you've completed 1.5 walls. The value of that wall is about 1,500. What was planned to be completed by now? Obviously, the planned completion was 75% as of today, which 75% of 4,000 should have been completed, which 3,000 worth value should have been completed. So there is a variance which has been created. Schedule variance is calculated as earned value minus planned value. So you've got earned value, you've got planned value. EV minus PV will give you schedule variance, which is a negative of 1,500. So we're behind $1,500 worth of time, like in terms of time. So time is also converted into money. And in terms of cost, we have already spent more money. So technically, if I talk about cost is the earned value that you completed versus what you've actually spent. So you've spent about 3,200 here, like, and the value that you've earned here is basically 1,500 only. So you have an extra spending done, but 1,700, which is negative variance for you. Now, technically, the concept of the SPI CPI is the only metric which is a meaningful sense. Will have a meaningful sense. How you did this CPI or SPI? It's called the scheduled performance index is the earned value divided by whatever is the planned value. If you look at the formula, you have to kind of understand memorize the formula. When I do this earned value divided by planned value, the value I get is this 0.5. What do I mean by this 0.5? What it tells me that when one complete day worth of work is done, time, in terms of time, 1 day worth of time is spent, only half day worth of work is completed in terms of time, not in terms of money. When I say 0.5, what it means that when my team will work 1 complete day, the output will be created, which will be only half day. That's what it means. So if my SPI says 0.9, what it means when team completes 1 day worth of work, 0.9 days worth of work is completed. If my team says that if this value of SPI is 1.25, what it tells me that my team works 1 day, they create the value worth of 1.25 days in terms of time. That work which would have been completed in 1.25 days, they have been able to complete in 1 day, which is great. So SPI, simple logic is it should be always higher than 1. 1 means on target, but less than 1 is a horrible situation. That means you have to do a fast tracking, crashing, do whatever to speed up because you're doing less work in terms of time and you're spending more time. So it is all in all, anything less than, in case of when you talk about less than 1 is a bad sign, more than 1 is good, on time is good. So it's like on target, which is also not good. CPI is earned value divided by the actual value. When you do this, cost here I'm looking at 46.46, 46 cents. What it means that if I spend $1, output worth of that $1 is only 46 cents. If I spend about $1, the output created from that $1 is only worth 46 cents. So technically, if I keep spending the money at at this rate, I'll only be creating 46% of that value, not 100%. If I'm spending $1, I'm getting 46 only. So I'm only getting 46% value of that $1. So the money which I'm spending, I'm getting quite less than that as an output. So for every time, if I keep spending money, I will only be getting 46%, let's call it 47%. So I'll be losing 57% of that money all the time. Every single dollar I spend, I'll be losing about remaining percentage of that value of money. So again, same logic. If my CPI says it's less than 1, it's bad. If my CPI says 1, like say 1.2, what it means that if I spend $1 worth, like $1, the output created is worth $1.2, which is great. I would always want higher than 1. So based on this, we calculate this EAC, estimate to complete. So given that now you are doing a bad job here, like in terms of money, you're spending $1, getting only 46 cents out of it. So at this rate, if you continue spending, so you will require how much? You will require $8,533. Even you spend $8,533, you will create a value worth of 4,000. To create a value worth of 4,000, you will require 8,533, because when you burn this much of money, that's when the value of 4,000 will be created, because you have a CPA of 46 cents here. And say, with that being said, you already spent about 3,200 already. You already spent 3,200 out of this. So you balance how much more will be required. It's 5,333. This is extra money that you need more apart from what you already spent. This is the extra money. So what is the variance that you have? The variance that you have is the 4,000, which was like the initial plan. But what you're now looking for is at the completion, because you expecting that at completion you only have 4,000. Now you're looking at expected completion is for 8,533. So your complete at variance at completion will be about 4,533. So again, I would not say that you cannot get a question about other formulas. So again, this is all we have to keep in mind. A, the codes. B, the complete name. Also, you never know. But yes, most common one is this. This is all. Well, what I expect, and I believe this is what you will be only getting, is you will be given a story, and on that story you will be given a SPI number or a CPI number. You just have to look at it and say, okay, it's good or bad based on that. So all in all will be easier. But again, please keep this in mind. You do pick this up, try to practice this, and try to change the numbers, change the values, and try to get comfortable. These are only things which you have to memorize from calculation perspective. There's no other calculation which is there. This can come. So yes, I would not say that this cannot come. Yes, it can come, but rarely people have seen it. Like this, I've not heard anyone personally telling me that I saw this, because everyone who appeared for exams, like this, I know the ones who have informed, they only got CPI, SPI, or metric. But again, please do work them out. All conceptually, you should know what they mean. But again, that needs practice, some bit of practice and repetition here. A quick check on this one. If anything needs clarity, again, but it's more about formulas. You can't do much about it. I have shared it already. I guess I shared it last week itself. It was shared in the last week, day 10, I guess. Day 10, I shared it. I'll just check it out. Is it okay with us? A quick check. This needs practice. Okay. One thing, let's do one thing. Let's take I guess will be it was shared last week itself. Pick one here. While the work is going on, we will be required to measure all these numbers and all that. We have to keep in mind while the work is going on, it will include the team and the external contractors also. We have to constantly monitor this, because of risk happening, you might end up doing extra, might end up burning more money than expected. Because of this, that can lead to delays, and as a result of there could be some potential disputes which might happen, and we'll talk about some bit of disputes here. So dispute can happen because of contract changes and all. So yes, there are potential risks which can lead to further consequences. So whenever anything which is typically related to dispute or technically with an external contractor, we'll have to keep in mind rule. You have a vendor. When a vendor is assigned to you, you give this person the acceptance criteria, inform this person about the job which needs to be done. This guy provide all the resources which is required for this person to do the job. This person is doing the job. Make sure you give the vendor the proper feedback and monitor this person doing the job. Do the quality audit. If the work is done, release this person. Inform the procurement team this person's job is done. Release the vendor. Bottom line. So during the entire thing, you have to keep in mind, if any dispute arises as a result of this, we will be required to go and check the compliance process. We'll have to inform the procurement team during the entire progress, monitor the progress. If in case there is some change from the vendor side, practically there will be some sort of advance notification. If the vendor is not able to do the job, they should be informed. So that kind of expectation setting has to be done. In the end, all in all, what I need is formal acceptance criteria, all the deliverables which were there. If the job is done perfectly, inform the product or the procurement team that you can release the payment, well, based on whatever the payment terms and conditions you have. As per the contract, you can release the payment. Bottom line, I am done, so I don't need this vendor anymore. The job is done. So all in all, every vendor, it's unethical to like hold on to money. If the person has done the job, well, we must pay them on time. That again are against ethical practice. We will be taking the break right now. So let's do one thing. Let's take the break. Quick one. Give me a quick moment here. So shall we take like we might need you want to take the regular like a 30 minutes break, or we would like to? Can you take the regular 30 minutes break, or like you want to come, because then we'll need a complete thing. Let's take the regular one. Let's take the just because we'll have to complete this, and like the 7 quality tools are just coming up. So well, let's take the regular one, and we'll be able to connect close on still before time. Let's take the regular break.
Mr. Satish, how many questions we can expect in calculation?
Not more than 2-3. I guess that's max. But again, I would still, these are pre-scoring ones. And honestly, if you have CPI, SPI, there's no calculation. Look at the number and decide whether it's ahead of target or behind target.
Okay, thank you.
Apart from that, you have to also monitor the non-human resources, which is about equipment. Everything is available. There's a price for everything. So equipment, material, facilities, infrastructure, anything that you've got, well, pretty much, if you don't need it, release it. Don't procure when you don't need it. So we will work with just-in-time approach. This is the approach used by Toyota as a company. The lean philosophy was introduced by Toyota, and they work with just-in-time. Well, the simple philosophy says we procure when the customer demands. So at the right time, at the right place, at the right quality, right price, right quantity. Nothing before, nothing after, just in time. So, well, bottom line, you don't procure when you don't need. You procure when you need it, when the customer demands, basically when the demand arises, and you release when you don't need them, because there is a cost for everything. So, and you keep monitoring the resource utilization. You're able to utilize the resource properly, and how many hours. If I've got a crane at my construction site and this crane is only used for 2 hours, I am blocking the crane. So try to see and how can we utilize this for remaining hours, because I will, like I know that I'm going to be utilizing it for 2 years. So I have to constantly monitor the utilization of resources, and yes, then take corrective actions according to it, so that we can ensure that the full and complete utilization of resource happens. So we're not paying unnecessarily for something which you're not using. That's pretty much on the non-human resource. So be it human resource, non-human resource, logic will remain the same. Don't procure resource when you don't need them. You release them when you don't need them. When the job is done, just release them. So try to optimize the resource, the performance of the people and for the machine or any non-human resource. That's all we have here. While you're doing the project and dealing with the project, there will be changes happening, which is by default it happens. So yes, we have the change request process in case of predictive. In case of agile, well, that is a part of, we don't have a process like that. Why? Because the agile nature is all about changes. And the changes are done whenever you have a sprint demo done, the customer can add those changes. And with those changes, you do a reprioritization of backlogs. So whenever those new changes are incorporated, we'll be going and reprioritizing it. It's the nature. So agile doesn't need to have a separate, there's nothing called change request in agile. Practically, because it's the nature. The process of Scrum will work and will include and will have an option of including the new items. So we don't have a change control board, a change request, nothing of that sort. And yes, there could be certain things which can result in a dispute. Well, whenever the dispute arises, where there's a conflict of interest happening there, well, we can always refer to the historical documents, how this was handled, and we may also include the procurement department, the legal team to ensure. Well, because it's not my job, I'm not the consultant, I'm not the right person to be taking a call. So I may include the concerned departments to look into it, because the vendor says, no, sorry, that's not my job. So, well, practically, I'm not the one who can get into that. So I will loop in the concerned people, and look, they will be able to sort out this issue, because contracts is what I don't deal with. So let the concerned people take the job and follow the historical procedures which are there. We'll give you a guideline, but honestly, as a project manager, it's not my job to handle disputes. Well, I needed a person, they got me the person. My understanding was clear, this guy is going to do this XYZ job. If you're saying, no, I'll do X, Y, but I'll not do Z, practically I'll have to go back and tell my procurement team that this guy has a dispute on the Z job. He's not doing it this job. He's saying it's not my job. It was not agreed upon. They will look into it. It's not what I can do, because it's not. I'm not the one writing those contracts. So let the concerned team take up. But how do we handle this? Well, we should know primarily what all their different methods will be. Just checking them out. So all in all, whenever the process is going on, we will be doing a lot of quality audits. And from quality perspective, because see, if I don't do things like quality oriented, I will be doing rework, defects, rework will happen. That will increase the cost, that will increase the time also, because I have to spend time correcting those defects. So my schedule will get impacted, my cost will get impacted. So it's very important with our work, what is done is always first and right. And it's all aligned with the customer's acceptance criteria. So my team should know what are they working on, and they should be creating an output. So while the work is going on, we will be doing quality testing, which is quality assurance team. We constantly work on designing and developing process metrics, would be creating training plans, would be doing audits, just to make sure the process remains in the perfect shape. Well, if the process, ideally that should happen. Having said that, whether the process did work as per the plan or not, will be checked by quality control team. Quality control team will be doing more of the Six Sigma kind of role, where they will be doing statistical sampling, data analysis, root cause analysis, and they will be checking whether the process actually worked as per the plan or not. So they will try to make sure it works as per the plan. So they will work while the process is working. But this is the output. When the output is good or bad, can be checked by the quality control team. And yes, if they find error, they will be creating performance improvement plan. They will suggest the corrections to the quality assurance team that, guys, your work process is not good enough. It's not helping. So these are suggested action plans based on our statistical testing, the quality audits we have done. We recommend you to make this adjustment in process. So quality control team will be doing this. So it's more around now going into the quality audit perspective, what all we do to ensure process remains under control. And in terms of quality, we do the quality job. So all in all, some methods we'll be talking about. So all what we already know, what happens in case of like a quality process, we know that there will be, the entire team should be clear about what is the acceptance criteria. We'll be working towards that acceptance criteria, and the team will verify, the quality control team, like quality assurance team, will ensure the work is done. But again, if the work is done correctly or not, will be checked by quality control team. So we verify as per whether deliverables meet those requirements or not. And if there are deviations, if it's not correct, they will do our statistical testing, identify those errors, do a root cause analysis, suggest the improvement so that the process can be corrected. And again, when the work is done, again, you verify now, is it doing perfect or not? So you continue to give feedback. That's a job. So we will be preparing a lot of reports and defects, like a recommendation, what needs to be, which is performance improvement plan. We call it PIP, which is recommended by the quality control team that you guys need to correct this. This is our finding from our root cause analysis. So we generally use something called 7 quality control tools, very commonly used, and we'll be checking them out right now. So very commonly used. And apart from that, yes, which is not recommended, like we'll be talking about them, that we'll talk into statistical testing, which is all about Six Sigma kind of job, which is where you get into data analysis and you kind of get into find out why something is happening again. In Agile, well, we don't have to worry about all this. Why? First of all, it's the way Agile works. It safeguards us. We don't have to get into all these hassles. Why? You have a backlog, you pull the items, That's an item which now we ask the customer, okay, tell me what is the need. So we're not planning everything here. This is all not, we're not doing a DOD for this. We have pulled the item, we're having a discussion. Well, you want to plan sprint one, well, discuss what. So it's a short duration, a very short duration, which is where we are trying to have a discussion. My team does the job. And yes, whatever you tell me, I'm just delivering it to. So whatever you ask me, there's few user stories we discussed, I'm delivering, and you're giving me frequent feedback. And yes, whatever feedback you did give, the team will do a retrospective, will understand, will make the correction. So feedback loop is in the process, inbuilt in the process, not like a separate department. It is the part. Unless you do that feedback loop, it is not going to, like in any which is the cycle will not complete. So the agile doesn't have, like, we don't need a quality team to do the job because it's a part of the structure, the flow. It will have to. So the team will do daily, like a daily standards. They will have a discussion. A lot of forums are there. So whenever we do the job, daily when we have the meetings, we will be having a discussion. What did we complete since yesterday? What are we planning to do today? And what were the impediments we faced? So this is one way we will have a quality audit having done almost every day. And apart from that, your retrospectives will be the period the demo period when you will be giving a feedback. The team will discuss. So it is a part of the entire flow process. So my team is just going to look into the feedback and continue to do the job, whatever the feedback, whatever the KPIs have been set for us, will be kind of working as per in compliance with that. So all in all, agile by default has it as a part of the way agile works. In case of predictive, we need to have is there a voice problem again? I just want to check. Because it's not been a problem now for quite some time now. Is it again, you facing some problem? Because I like see as if it's not clear, it will not be clear for anyone. Okay, so again, see, so I guess Mr. Zakar, again, I guess the piece there could be some bit of thing because like otherwise it may not be clear for anyone. Like so, otherwise, like it's just saying, some people are saying there's little echo. Why? And we're still talking about the same thing here. Let's see, just let me know in case if it happens again because I'm not sure what because there's still the same thing we're working on. Okay, that's quality audits. Again, that's what we are supposed to be doing throughout the project while we're doing it. So the quality team will be working as per the quality management plan to ensure that we are doing the work as per quality management plan. We'll be collecting data. We'll be doing statistical testing. We're talking about a Six Sigma kind of thing. We will be keeping in mind the cost of quality because the cost of delivering good quality, cost of the poor quality, the defect cost, all those will come into picture. The process design, basically the acceptance criteria that we have created, which is like how this is quality process will be quality assurance part. So all in all, when I'm talking about the overall process, the quality audits will be required. So when we talk about quality audits, the work will be done A, at the process level by the quality assurance team, B, by the quality control team. Quality control team will be working as per the quality management policy, and keeping in mind the acceptance criteria has to be fulfilled. They will collect data. That's what statistical testing happens. Analytical testing will happen, and we'll understand the defects and why it's happening and all that part. We can quantify that as what the cost of defect. So all in all, it's a part of all gain. Everything goes down to the quality audit. The quality audit process will come into picture, which is where we talk about these 7 quality control tools. These are the tools which your quality control team, and some of them will be used by quality assurance team also. So quality assurance team during the process and quality control team obviously will have more in-depth analysis of because they will get into data analysis also. So ideally the quality, the teams will be collecting some data through check sheet, checklist. Statistical sampling, again, this is the job done by quality control team, which is data analysis part. You can collect data through questionnaires and surveys. When you look at the data, you can look at the performance reviews based on what was expected, what is against the target, how we're doing. Again, some bit of data-driven stuff. Root cause analysis, again, statistical testing is required for this one. So all the statistical tools will be required, like the Six Sigma job role comes in picture. And these are the things we're talking about, 7 quality control tools. 7, these are only 5, I guess 1, 2, 3, 4, 5 written here. 6 is this one. 7th is missing in the list, which is flow chart. flow chart is the 7. So if we talk about there are 7 quality control tools, this list was developed by a person called Ishikawa. Ishikawa developed this list called 7 QC tools or 7 quality control tools. So these are 2, like 5 here, 6 is here, 7 is this one. So technically, I will be skipping this slide because I'll rather show you how it's done from a Six Sigma perspective. We'll not go into detail, but like just going to scan through this, and I'll just show you how it's done. All this stuff we are looking at. I have data, I can show it to you here. So all this stuff we'll just quickly talk through. These slides I'm skipping right now, going to that part where we'll resume at this slide now. After, like, so let's kind of go and check out the quality control part we're talking about. The 7 quality tools. Let me just open up some of this additional files. Let's check out this one. The 7 tools we have. So first tool, it's histogram. So in those presentations, you can see what's there. So all in all, histogram. This is the first tool we're talking about. Histogram is used when your data is quantitative. It first need is data must be quantitative in nature. That's what number data, production data, sales data, time data, cost data, do whatever you want. So we are talking about some sort of time-based data. So this is like a lot of numbers. I can't make sense out of this number. I can't memorize this number. And even if I memorize, what's the fun? What meaning does it give? Nothing. So when I use a histogram, it will help me analyze this data better. So I'm going to make a histogram out of it right now. Conceptually, from our PMP perspective, we all just going to be focusing from that because we will not get into Six Sigma level. But all in all, the purpose of histogram, we have to be clear about why we make a histogram. The data was numeric, quantitative, a lot of data. I can't make sense out of this. So when I make a histogram, this is histogram. When I make a histogram, I am able to see tentatively where is the average of the data, which is somewhere here. And so the average of the data is 18.643. It helps me to find where is the center of the data. It also tells me how low you can go, how high you can go, given this process, the variations which are expected in the process. So purpose of histogram is to find the center, which is the average, and the variation of the process, which is what we will be able to study. Any quantitative data, otherwise this numeric data is meaningless for me. So well, I'm able to now summarize this data by using a histogram. We'll be able to figure this out with a normal, like some sort of normal distribution. Again, that will not be get into that. More from the purpose wise, we should be clear. Whenever it's a quantitative data, to summarize and analyze the data, I will require a histogram. Then talk about check sheet. Check sheet is something which is where we collect data in kind of template document. Is there a standard format of check sheet? Answer is no. You can collect data in any format, any template, any document. Like attendance sheet is a check sheet. This is a check sheet. Your housekeeping guys maintain a check sheet. Audit sheet is a check sheet. Any sheet documentation, wherever you in a format or a template, when you collect data, that's a check sheet. That's for you to collect and store data. Flowcharts are meant for analyzing the flow of the process, how the process is flowing, like start to end, and we will be able to figure out from a lean perspective which department, where my work gets stuck. We start from here, go to here, from there the process goes here, where we finding most of the defects happening, most of the delays happening in the process, where process gets stuck. So in order to visualize the process, to see the waste in the process, I will be using a flow chart to see the end-to-end process of this one. I will put that. Yes, absolutely, Mr. Jafar. I'll share that. Coming to Pareto chart, the third tool. It is meant, the purpose of Pareto chart should be clear. It is used to prioritize by count, like something, prioritize something based on count. Let's see what is it. The purpose should be clear. Purpose is this. That's it. It is used to prioritize something based on count. Now, these are some complaints we have received in last 3 months. This is customer service data, and in our customer service, we have been receiving a lot of complaints from the customers. So in last 3 months, we have received 52 complaints from the customers because there was delay in attending calls, 27 complaints for language barrier, 15 complaints for some technical issues, and so on and so forth. So if I want to start a project, I want to focus on somewhere, I can use a Pareto chart. Pareto chart can be used to prioritize the more frequent complaints here. So, well, I can see from numbers also, but graph is like, it's always a picture is worth 1,000 words. So we always use graphs, it works best. So Pareto chart, type of complaint, the count of complaint, I don't want to combine, and let's see what it tells. This is the Pareto chart we are looking at. Now, if I look at Pareto chart, what it tells us, the most frequent problem that we had in our data was that delay in attending calls. We had like 52 complaints of delay attending calls. That's the first one. 27 complaints for the second one, third one. So it's a decreasing, look at this, it's in a decreasing order. And same, the numbers are in decreasing order. That's one. Then second one, we would look at this percentage. This is contributing 46% of my total complaints are because of delay in attending calls. 23.9% complaints are because of this language barrier. 13.3% of the total complaints are because of this. So these are individual impact of every complaint. Then it talks about cumulative percentage. It says 46% plus 23.9. If I focus on the top two, I will be able to solve 69.9% problem. I'll be having more focused approach. I can solve this top two, and that will solve my roughly 70% of my problem will be solved if I just focus on top two. If I focus on top three, I will be able to solve 83.2% problem. If I focus on top four, I'll solve 92%. So this is adding up as we move forward to 100%. So it is a way to prioritize. What logic of it is that if you try to focus on this one, you will solve only 1.8% problem. You solve this one, you only solve 8.8% problem. Your efforts required to solve this problem, or any problem, your efforts will be almost same or similar, but the benefits will be very different. Here you're solving only 1.8% problem by putting same effort. Why won't you not put that effort here and solve 46% problem? So Pareto chart is all about prioritization. See where the maximum damage is coming from and try to prioritize rather running into 10 different directions, solving 10 problems at once. Try to focus on few. So your focus is there, your teams, your work, your resources are not distributed, and you can have a dedicated effort on the most important ones here, the most frequent problems, and you will be able to solve a bigger chunk. So it's more about prioritization. It's not saying that others are not important, but right now, relatively, there are some other problems which needs more attention. So I'll rather focus on the top. It's also called 80-20 rule. Pareto chart is also called as 80-20 because this was developed by this gentleman called Wilfredo Pareto. Actually, Wilfredo Pareto was an Italian economist. He was given the task by the king in 1897. He came up with this Pareto chart, 80-20 rule, Pareto chart. He got it patented, 80-20 rule or Pareto chart, because the king wanted to understand how the wealth in the kingdom of Italy is distributed. So in the Italian kingdom, he did a massive survey and we came back with this result that 80% of the wealth in the kingdom of Italy was controlled by super rich 20% people. And remaining 20% wealth was distributed among 80% people. Huge inequality of wealth distribution. So Pareto got this patented in his name called Pareto chart and also got this patent of 80-20 in his name. He did nothing after that. It was Ishikawa who included this in the part of his quality tools, and then it became popular. For industry purposes, it was Ishikawa who used it. Otherwise, Pareto did nothing there. Ishikawa himself created this tool. Out of 7, he created one, which is called fishbone diagram. It's also called cause and effect diagram. Let's kind of look at this. So, as per Ishikawa, he said that if you're facing any business problem, the root cause of that business problem will come from 6M. Either the problem could be man-related, people-related issues. You may be facing a problem because of people. So you can talk about all people-related issues. Or the problem could be machine-related. Or the problem could be material-related. Or it could be method, which is process-related. Measurement-related, which is calculation or estimation-related. And then, or it could be mother nature, which is environmental factors. So here, this example is given for something called low productivity. So we're struggling with low productivity issue, and the team has brainstormed and come up with list of probable root causes. We feel that this could be the possible root cause because of which we're having low productivity. Now it's not verified. Discussion, just brainstorming. It's not verified. We will make a fishbone diagram, which is meant for finding if the purpose of fishbone diagram is to collect a list of probable, possible root causes, not real, possible root causes. We don't know whether they are root cause or not, but some experts believe they are root causes. So we use this for the purpose of finding a list of probable root causes. Verification will happen after statistical testing. So right now it's just a discussion. That's it. Low productivity is what we had the discussion about. That was a business problem, and we do our fishbone diagram. That's how my fishbone diagram looks like. If I want to change something, I can change whatever I want. I actually made up of us with a lot of flexibility in kind of changing whatever. It is done, and there you go. This is the problem about which we discussed. These are probable root causes which my team had discussed. That's a fishbone diagram. So the reason of fishbone diagram is to collect a list of probable root causes, which some of them may be the real root cause, which we don't know, which we will be able to verify when we do the statistical testing. Then comes your scatter plot. Now, scatter plot is used for data the way you look, whatever data you're looking here. Say, for example, we would like to find out if there is a statistical relation between the temperature and the sales of, say, air conditioning. So, well, is there a relation? Well, what we can do is we can take an average, like a temperature for the month, and we count the average sales for that particular month. So, like month on month, we have got some sort of data like that. I would like to find out if there is a relation or not. I would like to find out whether hours of study, right? Hours of study, does that have an impact on exam scores? I can do this scatter plot. So the hours of study are between, say, 1 hour to, say, 20 hours. So I'm randomly putting some numbers here. I want to find if there is a relation between the how much score somebody gets and the number of hours he or she would study. I would be able to do a scatter plot. For this, scatter plot is meant for finding a statistical relationship between two numeric data sets, and I will be able to check this out. I can do a scatter plot, which will help me figure out if there is a statistical relation. So I can do a scatter plot. I just randomly created one. And Y is the output variable, which is exam scores. Hours of study is the input variable. I can plot this and see if there is a statistical relationship. Do you see there is any statistical relationship here? And just one in one description. Anyone? Kind of no, yes. I would like to say kind of no. It's all scattered. It's all scattered. It's not. Well, have a look at this one. If you, the temperature and the sales of the air conditioner. You see a relationship now. Here. Yes. That does tell me a relationship here. When my temperature is less, my sales is less. As the temperature increases, sales increases. At a higher temperature, higher sales, higher temperature, higher sales. There's an upward trend. I see there is a trend which is going upward, and there is a statistical relationship. So I can draw a lot of relationships like that. These all come in very handy. Actually, we can predict also, but again, that will be out of scope for us to get in there. But again, scatter plot purpose should be clear to find a statistical relation between two numeric variables. Last one in the 7 quality rule is control chart. Now, control chart is meant to study the process, if the process data, the business data that you're working on, is that under statistical control or not. So when I process this control chart, and making one of the charts here, it will help me figure out if the process is in statistical control. When I look at this control chart, let's pick up this one. So it helps me to understand this X bar means the average of the data. And these are the data points. First day output, second day output, third day output, and this is like daily output we see here. And I see this is the average line. Average line is 12.57 is my average of the data, daily data. And this, when you see control charts are prepared, and when you see this is called UCL, is upper control limit. Upper control limit is the maximum limit, which is expected that my process will go up to this limit. My process will go lowest up to this limit. This is lower control limit. These are calculated and not given by the customer. Upper control limit and lower control limit are statistically calculated. What is the maximum possible this process can achieve, or the lowest possible this process can go. And whenever there is a violation, you will see this red dots. These are called special cause variations. If you see the red dots, it means that there is a change in the process. But it does not mean it's a defect. The red dot does not mean it's a defect. It depends what are you auditing here. So because if it's sales process, I would say it's a good sign. Why? I was expecting maximum sales to go till here. We've exceeded it. Great job. It's not a defect. When I say this data is about cost, then it's a bad sign. I was expecting my cost to go maximum to this. You exceeded the cost. It's a bad sign. So whenever you see this special cause variations, there is a root cause analysis required. When you do root cause analysis to understand why something has happened, why this is an exceptional value, well, we will have to we have to take action. So control charts will help you figure out whether my process is in statistical control or not. Let's say if I look at this process, let me just make it. Now, this process is in statistical control. This looks absolutely fine. There are no red dots. This is in control. So when I say this is stable process, statistically controlled process, whereas previous one was not a statistically controlled process because there were special cause variations also. So there was something to be investigated. So purpose-wise, we should know all these purpose of the tool. So what is the purpose? Upper lower control limits are not defined, they're calculated. Their control limits are calculated. There's a formula for, there are a lot of control charts. Every control chart has its own formula, how this gets calculated. Based on data, they will based on the formula of that control chart, you will have this calculated. So no, these limits have nothing to do with the customer. They are always calculated by the data, whatever we are. All in all, we will be looking. So whatever 7 quality tools, these are generally practiced by the people in the quality control team, and they will use these various tools and data collection practices to understand if my process is working under control or not, or there is some sort of corrections and adjustments required. And accordingly, they will be working on that like a thing, very much to solve it. Having said that, in case of Agile, we have this entire process of quality already inbuilt in the process. So whenever we deal with a job, it's involved by default is a part of the process we're dealing with in Agile. There is nothing called a quality control process, quality department, assurance department. No, it's all together in the process. So we don't have to get into that separate process because the audit is happening at the end of every sprint. You sit down with the product owner, discuss about the definition of done. When the job is done, you have an output created, which is instantly been audited and you get a feedback. So it's all as a part of this process. So it's linked with the process here. Having said that, the symbol, again, whatever the symbol given here, it's a wrong one because we talk about when you say this symbol, it is meant for Agile. The discussion which has been given here is related to the predictive one. So the symbol needs correction. In case of predictive, first one is the part of predictive. The second section is about Agile. In case of predictive, we will be working on the acceptance criteria, which are the quality metrics, and there will be some bit of plus minus which would have been agreed with the customer because, like for example, we have to build a wall and the thickness of the wall should be like 4 inches. You can't have exactly 4-inch wall. So you would have agreed with the customer while you having acceptance criteria decided the target thickness of the wall should be 4 inches. Plus minus say 0.2 inch is also acceptable. So plus minus can be there. So my team will be constantly ensuring and auditing whether the work has been done as per the customer target or not, and if the work delivered is within the acceptable tolerance or not. If it's outside the acceptable tolerance, then there will be a rejection which will result in change request. So we will, the same thing. Verified deliverables are presented to and accepted by the customer, resulting in accepted. We already know that part. So internal team will make it verified deliverable, quality control, and then this will be the customer will make it verified accepted deliverable. And this is done throughout the project for the entire process. Every deliverable has to pass. In case of Agile, practically we don't have anything as such. Why? Because we have, by default, it's done during the project. We don't have anything which is as a quality standard or something which have to be met within range. You have an acceptance criteria, like definition done. All you have to do is get the job done during, like, look at this. It's review in the Scrum. It is all part of the process itself. You don't have a separate quality control or quality assurance. It is all done as a part of the process. We don't have to have a plan such as, so you sit down, you plan, you then do the job, your product owner will verify it's done. If it's accepted, done. The deliverable is over. Pretty much whatever you have to use a story, you have to do. It's out from your backlog. The backlog work is over. The customer says it's acceptable, it's done. It's over. You don't have like sort of the tedious process like in predictive. And throughout the project, well, there is the only risk we have, like in case of predictive, we have a very, very like a robust approach to manage the risk. We have a risk management plan, like God knows what not. We do a lot of things to ensure the risk is not, when you don't come across that, you prepare a risk management plan, we prepare an issue log. Well, in case of Agile, we don't have anything of that sort. Why? Because what is the risk? Risk is that customer can keep on adding new. Every time you sit down for a demo, customer says, okay, this is fine. I have 10 more user stories. Every next time, again, I have 20 more user stories. The customer can keep giving more and more work. That's a big risk. So I don't mind taking that new work if you're being paid for that. So if you're giving me 20 more user stories, 10 more user stories, I'm up. My problem is that if you don't give me money and you want to add more user story, that's my risk. So I don't want so that's why my process of agile is already factored in that risk part of it by default. So that was one risk that I continue doing the job without getting paid. If I'm getting paid, then that's a good thing because I'm getting new business from the customer, which is good. I would love to do this. Let this guy do it for lifetime. Keep paying me and my team will be occupied and the business is going on. But well, for this, I'll say how much extra time will be required. Give me that extra sprint. I'll tell you for this 20, I will need